Hello. Here I'll talk about vectors in the plane, and this is an algebraic approach. Some terminology. Vectors, and I just Googled this. A vector is an object that is both a magnitude and a direction. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and with an arrow indicating the direction. The direction of the vector is from its tail to its head. Another term we will talk about is a scalar. And again, I just did a Google search for scalar. A scalar is a physical quantity that is completely described by its magnitude. Examples of scalars are volume, density, speed, energy, mass, and time. Other quantities, such as force and velocity, have both magnitude and direction and are called vectors. Now, the vector notation is done with these chevrons on both sides. So this vector AB is equal to this vector CD if and only if A is equal to C and B is equal to D. We have a lot of terminology here. Vectors are denoted with either bold text or with a ray over the vector notation. Vectors are also surrounded with chevrons. And unfortunately, I will not always use this style when writing vectors. Sometimes I get carried away in the math and I forget about the proper notation of a vector. So the length of a vector, and this is supposed to be bold, I guess I can also mark it with the line. So if vector v is equal to v1, v2, then so up until now, you've probably seen these two lines as absolute value. From a basic algebra point of view, the absolute value, whatever, this is a number generator, so whatever number goes in has to come out as non-negative, although that is a 100% true statement. More into these vertical bars, this denotes a quantity, this denotes a magnitude, this tells you how much you have. And so if we have like say -3, well, we have 3 of them. Something else, this is also a distance on a number line from 0 up into that point. So this is a magnitude, this is a size, this is a counting how much there is there. So the magnitude of v, your vector, that's just how big your vector is. Well, this is shown by, this is the Pythagorean theorem. I'll show it you in a couple of examples, but it's going to be the square root of v1 squared plus v2 squared. So that's the magnitude of the vector. Now, if the coordinates of the points P and Q are px1, y1 and qx2, y2, then vector PQ is equal to x2 minus x1 and y2 minus y1. Now, here your orders do matter because this PQ, this vector begins at point P and ends at point Q. So therefore, you will subtract the Q, it'll be Q minus P, Q minus P, 2 minus 1 in both instances. Vector addition, if vector u is equal to u1, u2, and vector v is equal to v1, v2, then if we add the two vectors, we need to add their x components and add their y components. If we subtract the two vectors, then we subtract the x components and we subtract the y components. Scalar multiplication. So if a k is a scalar, k times your vector v, well, this is equal to kxy, and you would distribute that k in for all of the components of your vector. The unit vector has length 1, so you have the I vector. This is equal to 1, 0, and the j vector is equal to 0, 1. This is if and only if xy is equal to x times the I vector plus y times the j vector. Okay. Sketch each vector in an xy coordinate system and compute the length of the vector. That should be over 5 and up 12. Okay, that is the vector. It has x coordinates of 5 and y coordinates of 12. The length of the vector, is a distance formula. Pythagorean theorem. So the distance from the origin to the point 5, 12, or it's 5 squared plus 12 squared equals c squared. So the magnitude of the vector, the size of the vector, is 13. So that's the vector. The length of it, So that's sketching it, and that is the length of it. That's the sketch. Determine the components of the vector PQ. Okay, so this begins at P and ends at Q. And so we need to do, this is my x2, y2, my x1, y1. You can always add the opposite. So let vector A equal 2, 3, vector B equal 5, 4, C is 6, negative 1, and D is negative 2, 0. Compute each of the following. Okay. So C and D is going to be negative 2C plus positive 2D. This negative 2 is a scalar. It's going to be multiplied into the C vector. Negative 2 times 6 is negative 12. Negative 2 times negative 1 is positive 2. And then this 2 is a scalar times the d vector. Positive 2 times negative 2 is negative 4, comma 0. And then when I add the vectors, negative 12 plus negative 4 is negative 16, and 2 plus 0 is 2. I think I want a calculator for this. So before I go on, let me just check the arithmetic. Okay. Now let's see if this can be, how far it can be simplified. Since I had a lot of 5s in here, I divided this by 25. And because it's a square root, we have a product, the square root of 25 turns into a 5. The only factors of 130 are going to be, we have 5, and you have 13, and you have 2. No perfect squares in there. 10 times 13 is 130. Thank you very much. Please go to tutoring.